Hello, our topic for discussion is affordable solar energy, and we're going to be discussing its background, its current designs, and its future developments. My name is Jorge Coria, and we also have...
My name is Jorge Cisternas.
And my name is Jorge Fontus.
There are 10 energy sources right now available to human beings, with the non-renewable sources to the right and the renewable sources to the left. All of these resources are eventually going to run out, so we need to find a way to produce more energy with the renewable resources, with solar being the largest one and the one that's able to produce the most amount of energy. So, as you can see here, 51% of the energy is being stored and absorbed by the land and the oceans. If we are able to somehow store this energy and produce some type of energy on it, we'll be running at 100% efficiency. However, as my teammates will further discuss, we are only running at around 41% efficiency. In 7th century BC, the first use of solar energy was used to lit a fire using a magnifying glass. This was done by using the magnifying glass to reflect the energy from the sun and lit a fire. As the Greek and Roman empires came along, there came a need to light up torches for religious ceremonies. They did this by using burning mirrors and reflecting the energy to lit the fire. The same concept was used by Archimedes in 212 BC to win the Battle of Syracuse, which he used bronze shields to reflect the energy and lit the ships on fire. And the Native Americans later on also used solar energy by storing it and using mirrors. They did this because the weather was optimal where they lived, in places such as Arizona and New Mexico. In the 1700s, Horace Sasser created the hotbox, as you can see in this picture right here, which was the first cooking device using energy completely from the sun. This was done by using also a mirror and lighting a fire on it, and human beings were able to cook with energy from the sun. Clarence Kent later on created the first solar heater by using the same concept and storing it in a box and producing hot water. Human beings were now able to take hot showers using energy completely from the sun. This was a success, and people were able to take hot showers. Albert Einstein, in the 1920s, discovered the photoelectric effect, which will be further discussed by my class teammates further on in the discussion.
Today, one of the more promising methods for harvesting solar power comes through the use of photovoltaics. Photovoltaics were designed in the second half of the 20th century through the use of the photoelectric effect, which essentially describes a process from which photons of light will hit a surface and cause electrons to bounce off. Researchers realized that by connecting two semiconductors of opposite charges and reenacting the photoelectric effect, currents were produced and thus electricity. The most basic design for this purpose is called the PNN junction and only uses two semiconductor layers, one for the positive side and one for the negative side. This design in particular was effective, or was successful in producing electricity, but was not very high in efficiency. Later developments of the photovoltaic cells include multi-junction systems where several layers of semiconductors were connected and efficiency was increased. The production of photovoltaics can be done in two ways. Essentially, they're all cells, but they could either be rigid cells or they could be thin film cells. Rigid cells are thicker and have more efficiency, but thin film are very flexible and have more practical uses. Regardless of which you consider, solar power is harvested when these cells are arranged into larger modules and then arrays. Modules will determine the voltage capacity of an array, and the array is the finished product which you typically see at homes installed. Affordability. Solar panels and any photovoltaic technology is still fairly expensive for the average individual. It costs a lot of money to buy up front, to install, and to maintain. It also offers very thin margins and a long payback period. Only specific parts of the world actually have the potential of making profit off of these products. But in some places it is so that companies are willing to give the equipment for free so long as you let them use it first at your location for several years. This is a trend that's called leasing, and it's become very popular in places like Germany. Additionally, in certain places, the functionality of solar power is very little due to the fact that not a lot of light shines there. This essentially brings down how much they can produce, and the less you produce, the less money you make, the less money you make, the less affordable in a sense it becomes. How can this change? Well, the good thing is that it is changing. In order for solar power to become more affordable, a couple of things have to happen. Multi-junction cells need to become more efficient, but at the same time cost less to produce. That way, when they are used for solar production, solar power production, you will be overall getting more profit. Additionally, functionality of solar power cells needs to go up, as there are very limited places in which solar power at a utility scale can actually produce and provide electricity due to things like nighttime. In the horizon, there's a new technology coming out that is very promising and is sort of bridging the gap between many of these issues, and it's called concentrated photovoltaics, where the idea behind it is that concentrated light into photovoltaics will reduce the amount of material required in order to produce the same power, and thus bridging the gap between the technology that is now and the term affordability. All in all, we should be able to see, or we should start to see, photovoltaics as a competitive source of solar power rise in the near future, maybe within a decade or two.
Concentrated solar power systems are another viable option for affordable solar power. Essentially, in this process, mirrors are used to direct the sun's energy to a receiver. In the receiver is a working fluid that is able to transport high temperatures. The high temperatures are used to heat water, which turns into steam and is pushed through a turbine. The turbine powers a generator, which then creates electricity. In concentrated solar power systems, mirrors are attached with tracking systems. In this particular type, line focusing systems, the sun's energy is tracked in one X linear direction. For example, in a parabolic trough collector, curved mirrors are used to direct the sun's energy to a focal point where a receiver carries working fluid in one linear X direction. In a linear Fresnel collector, flat mirrors are used to direct the sun's energy above it to a receiver, which also flows in a linear X direction. In a point focusing system, tracking systems are provided in the X and Y direction. For example, in a solar tower plant system, a solar tower is placed in the middle and on top is a receiver. Around the solar power plant are mirrors. The mirrors direct the sun's energy in a Y direction, and the receiver then uses the working fluid to flow down in an X-wards direction, creating the process. In a solar disk system, mirrors are constructed in a satellite form, directing the sun's energy towards a Stirling engine. The Stirling engine uses the heat to expand a fluid which creates mechanical work. The mechanical work powers the generator, which then creates electricity. With regards to affordability, concentrated solar power systems are expensive. The components needed to complete the process are what makes it this way. As described in previous slides, mirrors are needed, receivers are needed, working fluids are needed, turbines, generators, and working fluids. So with all these components, the prices are increased. Also, due to the nature of concentrated solar power, it must be placed in areas where there is a lot of sun, which is deserts. Because they're placed in deserts, water is scarce around the concentrated solar power systems, which causes water to be transported, which also increases the price of concentrated solar power systems. Now, the solutions to these current designs will be replacing components in the process, such as water. There is research being done to replace water with a fluid called supercritical carbon dioxide. Tests are being run to show that water can be replaced with this source and used to power turbines. Also, parts of the process can be replaced, such as heat storage. If a heat storage is added to a concentrated solar power system, even though the sun is not out at night, the system can still run without the sun's energy. Solar energy has made innovative leaps and bounds towards solving our world's energy diversity needs. However, with respect to affordability, future developments must be applied. Water must be replaced with another source. Materials must be found that will decrease the cost of solar energy systems, and also heat storages must be applied to solar energy systems. Compared to other energy sources, solar energy is at its infancy. So with the application of future developments, solar energy has the potential to become affordable and beneficial to our society.